Hello. In CBSE board, 12 questions are MCQ. So these are very important. All these types of questions in CBSE board. So we are discussing MCQ for the chapter nucleus. And this is the first question here. In uranium 235, one single fission of nucleus will give 200 million electron volt energy, then 1 kilowatt means 1000 joules per second number of fissions required. So this is the question. Now in the question it is given one fission equivalent to energy 200 million electron volt of uranium fission. So 1 kilowatt means this is the power or 1000 joules per second. So we know this relation 1 million electron volt equal to 1.6 into 10 to the power minus 13 joules, or 1 joule will be 1 upon this million electron volt. So by converting from joule to million electron volt, we have to divide it. So it will be 1000 divided by 1.6 into 10 to the power minus 13. It will become million electron volt. So 200 million electron volt will give the one fission. So number of fissions required to get the 1 kilowatt power, the number of fissions will be equal to this divided by 200. We solve it. There are the number of fissions required. So here we solve this. We are getting the calculation, this 10 upon 3.2 into 10 power 13. It will be roughly 3.125 into 10 power 13 fissions. So if this much fissions are required to give the 1 kilowatt power. So option 1 is correct. In this question, mass of hydrogen atom and mass of the particle is the force given by F, Newtonian force, F equal to G m1 m2 upon r square, where m is the mass of the particle, capital M is the mass of the hydrogen atom. We have to find out the relation. They are separated at a distance of r. And we know the bonding energy is equal to mass of reactants minus mass of product into E square. In hydrogen atom, so reactant means mass of proton and mass of electron minus mass of hydrogen atom. So here P binding energy divided by C square MP plus Me minus mass of hydrogen atom. Here in this question it is written M. So this way we can find mass of hydrogen atom means mass of hydrogen atom M. It will be MP mass of proton plus mass of electron minus bonding energy divided by E square. So here this is the option 2 is correct. Hello, in this question is the equation for hydrogen atom. We combine them, we are getting the helium nucleus, and here ionization is formed to electron, and we are releasing the energy 26 million electron volt. So if we combine them, combination of smaller nuclei to bigger nuclei is called fusion reaction. So this is possible reaction is only fusion, not fission. So option 3, only fusion reaction possible. Hello, in this question, radius of aluminum is, suppose this R aluminum, and radius of tellurium we have to find. So here we know radius is directly proportional to cube root of the mass number. So radius of tellurium upon radius of aluminum given as here mass number of tellurium upon mass number of aluminum cube root. So it's given 125 in the question, and this is 27. In the cube root it will be 5 by 3. Therefore our tellurium will be 5 by 3 of case of aluminum. So option 4 is correct. Hello, in this question, in nuclear reactions, we know mass is conserved, energy conserved, momentum, linear momentum is also conserved. We know mass, energy and linear momentum conserved, all are conserved in nuclear reaction. So option 4 is correct. Hello, in this question, X is the atom, Z is the atomic number, is mass, it is breaking, and a new nucleus having say Z plus 1 atomic number and mass number, this no change, and this is the electron and this is the anti-neutrino. Say electron. If we know the electrons are coming out or ejection of electrons from nucleus, they are called beta particles. So these the same electrons, if they are coming out from the nucleus in the reaction, it is called beta particles. So it is called beta decay. Means here option 1 is correct. Hello. In this question, the fission of properties of plutonium 239, that is similar to uranium, average energy released per fission, that is 180 million electron volt of fission of plutonium. If all the atoms in 1 kg mass of plutonium, then we have to find the total energy released in million electron volt. So here first we have to find the number of nuclei present in 1 kg of plutonium. So first we have to number of nuclei present in 1 kg of plutonium. Then in the question it is given in one fission energy released given in the question is 180 million electron volts. So total energy required will be number of fissions multiplied by energy released in one fission. So first we have to find the number of nuclei present in 1 kg of mass. For that we know Avogadro concept. Now we know in 239 gram of plutonium number of nuclei present equal to Avogadro number 0.023 into 10 to the power 23. Then 1 kg or 1000 grams number of nuclei will be 6.023 10 to the power 23 divided by 39 multiplied by 1000. After calculation coming here 2.52 to 10 to the power 24. Here the number of fission. If we put it in equation 1, we get total energy equal to number of fissions means 2.52 into 10 to the power 24 multiplied by energy in one fission 180 million electron volt. So here it comes 4.53 to 10 to the power 26 million electron volt. So after calculation we are getting here 4.536 multiplied by 10 to the power 26 million electron volt. Round off करके 4.53 10 to the power 26 million electron volt. So matching. Anyway, option 1 is correct. This is very good question. This is 1 million electron volt positron and 1 million electron volt electron. They are traveling in opposite direction. If they combine and converting into photons, we have to find the wavelength of the photon phase. The rest mass energy of electron and positron is given the same and Planck constant is this. So we have to find out the wavelength of the photon produced. Now we know the total energy equal to kinetic energy of electron and the rest mass energy of electron plus kinetic energy of positron and rest mass energy of positron is given in the question. Kinetic energy is 1 million electron volt plus 0.512 million electron volt per electron and the same here for positron. 1 million electron volt kinetic energy and 0.512 million electron volt is the rest mass energy of positron. So if we sum all these, we are getting 3.024 million electron volt total energy, and this is the total energy which is converting into photons. Now this is equation 1 and we know the electron and the positron, if they combine, we are getting 2 photons. It is the reversible reaction. So electron and positron, if they combining, we are getting 2 number of photons, 2 photons. So you can say by this equation 1, we can say here energy of 2 photons, this is equal to, as per equation 1, 3.04 million electron volt. If we convert this energy to say joules, we have to multiply with this 1.6 10 power minus 13 joules. तो सॉल्व करने से हमको मिल रहा है minus 13 joules. This is the energy of 2 photons. So now energy of 1 photon will be this divided by 2 joules. तो सॉल्व करेंगे तो हमको मिल जाएगा 2.4192 10 power minus 13 joules. This equation 2. Now with the energy is equal to h by lambda is the energy, h is the Planck constant, c is the speed of light, and lambda is the wavelength of the photon, can be found hc by E. H Planck constant 6.62 into 10 power minus 34 and CH3 into 10 power 8 divided by energy, this 2.4192 10 power minus 13. We solve this one, we are getting it 8.209 10 power minus 13 meter, or approximately 8.2 10 power minus 13 meter is the wavelength of the photon. So here this is the option 2. Hello. In this question, how much energy approximately released all the atoms of 1 kg of deuterium could undergo fusion reaction? So here energy released in per deuterium nuclei, that is it, 2 billion electron volt. So we have to find out the total energy required or released. So here first we have to find how many atoms or nuclei in 1 kg of deuterium. So number of nuclei in 1 kg of deuterium is given by the Avogadro number 6.023 into 10 to the power 23 in 2 gram of weight, and 1 kg 1000 grams. So we are getting gram cancel out. We are getting this 6.023 into 10 to the power 23,000 nuclei in deuterium. So we can say here how many atoms are there, how many nuclei will be, there are 2, so we have to divide it by 2. The number of nuclei we are taking of deuterium will be 3.0115 10 power 26. Now 1 deuterium is giving 2 million electron volts, so total energy released here will be 3.0115 10 power 26 multiplied by 2 million electron volt. If we convert into joule, then 3.0115 multiplied by this into million electron volt to joule multiplied with 1.6 into 10 power minus 13 joules. After solving, it is roughly 9.60 something 13 joules. Here it is 9 10 to the power 13 joules approximately here. Or this is matching with the answer. Option 2. So here option 2 is correct. This is a simple question. We have to find out the equivalent energy of 1 gram substance. So it is very simple. Nothing is there. Energy, bonding energy is equal to what? Mass defect multiplied by E square in joules. So there is no conversion. 1 gram convert into kg. 3 into 10 to the power 8 square of it. Solving it and 10 to the power 13 joules. So option here is 1. Simple question. Hello. In this question, we have to find in this nuclear reaction, masses are given in AMU, atomic mass unit of the reactants and the product. So we have to find out the energy Q. We know here this bonding energy E equal to delta M into E square. In joules, this energy can be written, this we also delta M if it represents in AMU mass, or U, sometimes only U is written for AMU mass. Conversion here is 931.5 million electron volt. We know this 1 AMU mass, equivalent energy calculated 931.5 million electron volt. So here delta M, the mass of reactant minus mass of the product. So this energy can be written like mass of A plus mass of B minus mass of A. It will be 1.002 plus 1.004 minus 1.001 minus 1.003 into 931.5 million electron volt. That is 2.006 minus 2.004 into 931.5 million electron volt. So this is 0.002 multiplied by 931.5 million electron volt. So this is the energy after calculation, getting 1.863 million electron volt. So this is option 4. It is very nearest to option 4. In this question, mass number of iron is 56. We have to find out the nuclear density. Now we know nuclear density is given as m upon 4 by 3 pi r naught cube, where r naught is the constant, empirical constant 1.2 for me, and this is the constant quantity. It is not depending on mass number, so it is a constant quantity for all. We know the calculation result 2.29 into 10 to the power 17 kg per meter cube. So option here is 2. Hello, in this question we have to find out the bonding energy of this reaction. Energy, how much energy is released. It is given in the question. Bonding energy of deuteron and bonding energy of helium is 1.1 million electron volt and 7 million electron volt. If two deuterons fuse together in fission reaction and forming the helium nucleus, how much energy is released? So it is the energy released is the energy difference. As the energy released here equal to helium 4 multiplied by 7 million electron volt of helium minus deuterium 2 multiplied by 1.1 million electron volt, and there are 2 deuteron nucleus. So 2 deuteron multiplied by this, for just 28 million electron volt minus this 0.4 million electron volt, and difference coming here is 23.6 million electron volt energy released here. So option 2 is correct. Hello, in this question, how much mass has to be converted into energy to produce the 500 megawatt power in just 1 hour? So energy here, but the energy required means power multiplied by the time. So here power is given 500 megawatt, converting into watt, and time will be seconds. So 1 hour means 60 into 60. This is the energy this is the formula of the energy. This is the energy required here. Now we have to find the mass. So we know energy is equal to delta m into c square. Delta m can be found by say energy divided by c square. Energy 500 10 to the power 6 into 60 divided by c square, 3 into 10 to the power 8 whole square. Solve it, we are getting the mass 2 into 10 to the power minus 5 kg. So option 1 is correct. So in this question, mx and my denote the atomic mass and the daughter nuclei. In the radioactivity decay, the Q value of beta decay Q1 and beta positive means electron here decay. So beta decay means nucleus and electron means the atom. If we know this, then say Q1 is the energy, is the mass defect of nuclei. Beta decay means there is no electron involved here. C square. If we talk about say electron decay, this is the difference here, and electron, 2 electrons are coming out, so it will be 1 from say mx my. So 2 mass of electron is the mass defect in case of atom. This is the mass defect of nuclei. So option 1 is correct. Hello, this question, the stable isotopes of lithium, Li6 and 7, and abundance 7.5% and 90.5%. These isotopes having mass 0.015112 U Newton and 7.01. So we have to find out the average weight of lithium. So here the formula atomic weight is given as the mass of isotope of lithium, abundance means availability of this lithium. Similarly, for mass of lithium 37 2 hence of M7. Abundance means availability of these isotopes. We solve with mass of isotope lithium 36. It is 6.01512 U. Mass unit availability here is 7.5%. Mass of M37 is 7.01600 U. Percentage availability 92.5% on this. We solve, we'll get say atomic weight, that is say 0.45113 U plus 6.4898 U, coming here 6.94093 U. So the atomic weight option here is, abundance के क्वेश्चन आते हैं बोर्ड में, कंपटीशन में भी, तो इस तरह के क्वेश्चन देखिए ये वाला फॉर्मूला पता होना चाहिए. Hello, in this question boron is bombarded with a neutron. Alpha particle helium nucleus is emitting out and the resulting nucleus is formed. We have to find out the mass number of resulting nucleus. So it is simple question. Here we know boron and the neutron. Resulting here is helium nucleus plus daughter nucleus. We do not know. We have to find out mass number of the daughter nucleus. So if we add here left hand side charge conservation law 5 plus 0, here 2 plus 3. So Z will be the charge conservation law 5 plus 0, here 2 plus Z. Z will become 3 and mass 10 plus 1, 4 plus A, it is A will be 11 minus 4, that is say 7. So answer 7 is here. Option 2 is correct. We have to find out the ratio of nuclear radii of gold isotope and the silver isotope. We know your radius of gold and radius of silver given by mass number of gold and mass number of silver. Over here 1 by 3 is 197 by 107. Cube root of this 3, 1 by 3. Here it is roughly coming 1.23. So here option 1 is correct. In this question, MP is the mass of proton, Mn is the mass of neutron, and M1 is the mass of and M2 mass of this. So neon, calcium, M1 mass for neon and this M2 mass for calcium. We have to find out the relation. And we know the mass of reactants and mass of product. Mass of reactant more than mass of the product. But the reason here is some mass is converted into energy. So mass of reactants must be more than mass of product is less than the mass of this. So here M1 is the mass of product should be less than 10 number of protons and 10 number of prons and tons and 10 number, this is in neon. So here option 4 is correct. This is the concept we know, some mass is converted into energy.